Let's have a look at an interesting CAM application. Today we'll explore common uses of probing as part of EDGECAM toolpath. In this first application example, we see a part loaded onto a horizontal machining center. The part has had some previous machining, and the beginning of the program starts with using a probe to update the work coordinate system based on the probed locations. So we see the directive, update the work system, G54 in this case. After the probe has updated the work system, machining continues, and then at the end of the program we see the probe is called back, and this time we're measuring specific part features, some critical holes in this case, and ensuring that we have a quality part. As with anything else in CAM, we expect to be able to simulate, to preview the tool path, make sure everything is collision free, and that the motion is what we expect. We see here at the start of the program that the probe touches 4 points on the finished part to set the Z, and then probes the machined diameter to center up XY to set the datum. Now that the datum's been set to the part loaded into the machine, the machining and material removal actually begins. We'll show the very beginning of that and then jump forward to nearly the end of the machining. So as we approach the end of the machining, the drilling, face milling, pocketing, all's been done. And the last tool loaded up to remove material is going to drill several holes on the face of the part, finish the drilling on those, and then the rotary table is going to index. This drill will take care of one more hole on the flat at the side of the part. And after that, we're going to bring the probe up. We're going to see the measuring function. As always, we see the machine motion. The rotary table is indexed back to 0. The probe touches the flat on the part to check for flatness, and then measures the holes to ensure a quality part. This application example shows a mill turn. The touch probe is used to update the work datum, but this time by probing on the face of a cast part, then the bore, and then located on a flat for 0-degree alignment. So, does your CNC machine have a probe? These smart devices are widely available in many CNC machines. They can be used for a range of tasks. The most common usage is to assign or modify the work coordinate system. This is often done by machinists as part of CNC machine setup. Many modern CNC machines have onboard software to simplify programming and operation for this common task, but there's much more that can be done with a touch probe, such as measuring the machined part. This task is considered process security. Perhaps we simply intend to capture the dimensional inputs and store them for part certification purposes and quality assurance. There are also a variety of possible actions that could be taken based on the probing results. For example, if the results are approaching tolerance limits, an appropriate action might be to update tool wear offsets, or change to alternate tooling, or remachine a critical surface, or even stop production until a machine operator resolves the problem. The pinnacle of probe use is full inspection of the machined part. If your company is already moving into full-on machine inspection, please reach out to your account manager to discuss this application further. This demo is focused on the widespread need for CAM programming that includes use of the probe for datum setup and measuring machining results. These are highly productive and leverage probe systems technology that is widely available on CNC machines. The EDGECAM technology shown here is core software capability. It's not a productivity app developed by a third party. This means that adopting EDGECAM's technology into your company's manufacturing process will work and will likely be plug-and-play integration. We'll be using software commands developed for inspection and probing. These commands are easily added to the software interface simply by turning on the inspection panels on the Features and Machining tabs in EDGECAM's ribbon. These commands are used to quickly create probe features using the solid model and probe toolpath. CodeWizard supports probing technology on all major templates. Because EDGECAM's probing technology is core software capability and not a third-party app, CodeWizard can easily add the probing technology to any modern post-processor. CodeWizard is the valuable app for post-processor work, which is included with all software licenses. EDGECAM users often take for granted that existing post-processors can be easily updated and continually absorb new technology, but this is a challenging task for other CAM platforms. EDGECAM users have ability to work on their own post-processors, and this includes easily handling technology updates. So what does this integral software capability get me? Great question. It means that EDGECAM works with probes from any manufacturer and across FANUC compatible, ISO, Siemens, and Heidenhain TNC controls. Put another way, EDGECAM's probe technology can be used with practically any probe on practically any CNC machine. Some customers may also be asking if this is new to EDGECAM. True, we have had probing technology for well over a decade. The technology has been redeveloped, and by aligning probing with EDGECAM's Inspect technology, the software's probing capability has grown significantly. In addition to supporting a broader range of CNC controls and probe hardware, users also have a greater ability to tailor probing to their application requirements. Let's have a close-up look at how this new probing technology can be used. This will include showing how probing support can be easily added to existing post-processors. As we show what goes into creating probe toolpath, I want to begin by pointing out that we have a part with some work completed already, and the virtual CAM setup stock and the machining fixture have been added to the setup and connected to the machine. That includes setting the datum at the mid volume of the stock. We can see that there's features created, and that includes not only the features for machining, but also features on the corner and top of the part that we'll use for probing. There is not any tool path built yet, and so let's begin the process as normal with choosing a tool from the tool database, in this case looking at the specific tools in our current CNC machine magazine and choosing a touch probe and stylus that's already in the machine magazine. Once the tool is called down, we can immediately start with the type of work we want to do. And in this case, I want to probe the corner of the part, so we'll choose an appropriate command and configure the command with the parameters that we want. In this case, our clearance planes, how much off the part to start, over travel allowances, and the function that we want to do. In this case, update the work datum and update the G54 datum at the machine. After pressing OK, we can select the target to machine. In this case, those features right there. And immediately, we can see the probe tool path is built. We can now move on to selecting the point at the top of the part. Again, similar inputs, direct what I want to happen, and then select the target, the point in this case that we want to work with. Let's generate code and see the results of that. We'll bypass the job kit for the time being and focus just on the NC code. Notice the NC code contains all the commands that we need to integrate with the probing software resident in the machine control. Next, let's go look at the same part with the tool path already built. So not only has the probe been used at the beginning of the sequence to update the work datum, but then tool path has been built to completely machine the part, and now that we're done with that, we want to bring back the probe to inspect some critical areas. We're going to need to have features on those areas. So let's go over to the Features tab and add them on. Let's add in a circular face. So select the circular face to work with, and immediately a feature is created. If we edit that feature, we can make adjustments, such as perhaps how deep we want the probe to be driving, and even tolerance information on the part. Let's modify the tolerance that we're looking for here to go to 4 places and not 5. We can immediately see that feature update. Let's also add a width feature to the part. So I want to probe the outside, perhaps right at that location. And if you notice, what's happened here is that that feature that's created recognizes the true width that's needed at that area. And we can make edits if we need to, but I believe that feature will be fine. We can immediately go to machining. As before, the process begins with going out to the database and choosing our probe and loading that data down to CAM. Once that's done, we can immediately select the type of work we're going to do. Let's start with probing the circle that we created. As before, we'll put in our parameters to work with. We'll continue to use a safe link method here. And we can put in the function. In this case, I'm going to do a measure function, simply to measure things and output to a print file. Notice that there's a variety of controls that we can add to the probe cycle, including even variables that can work with logic that we embed in the post processor. After selecting the inputs, we immediately see the motion that's built, just like any other motion in the CAM software. I'm now going to go probe the width on the part. Again, put in the inputs that we want. After selecting the inputs, the target to machine, again we see the path built. And as before, we can generate code as well as simulate the motion. As we simulate, we see the machine move into position. We see the probe motion happening. Let's rewind that, and let's, in this case, actually turn off the enclosure and the base of this machine and focus in on where we're actually doing the work. Notice the probe stylus. We can accurately see the stylus. We can see where it's doing the work. The probe hits, and just as with everything, collision checked in the entire environment. If we fast forward down near the end, one of the last things that happens in the part is some deburring. So let's watch the completion of the deburring. And then we're coming back with the probe. We see the hits on the circular boss as well as the outside of the part, all collision free. And just like anything else with EDGECAM, that confirms that we have a good process ready to post code, and immediately we can take that code, send it to our machine, and run it. In this case here, the code, as before, contains the probe motion at the top of the part, all of the tool path motion that's been built in to remove material, probe coming in at the back end, and this can be customized, as we'll show next, via the post processor. Let's close the code and go back to the EDGECAM launcher and down to Code Wizard. Code Wizard is a tool that allows EDGECAM users to work with their own post processors. It's the same tool that Hexagon as post processor authors and many resellers use as well. As we look at this existing post processor, it is a modern post processor but does not yet have the probing capability. So when we go into add a device, we can add inspection and probing, and after pressing OK and updating the template, what's happened is that now in the code constructors area, there's a new category that's been added called inspection probing cycles, and this is put in to directly integrate with the factory probing capability. So when we look at let's say the probe circle code constructor, to pick one at random, notice there's a list of valid tokens like we would expect in any code constructor, where we can take and prepare an output string. So if we have a machine that uses a different call than G65P9814 in the case of this particular post processor, that information can be adjusted to align to the machine's onboard inspection software. All of the data in this row can be arranged, and we can even add in additional logic that might use the variable set up from some of the probing calls in EDGECAM to direct exactly the type of code output that we would like in these different situations. In summary, EDGECAM's probe technology can be used with practically any probe on practically any CNC machine. This has been a demonstration of the EDGECAM probing module, which adds the commands needed to create features and toolpath for these probing applications. The resulting NC code is tailored to match the requirements for the onboard probing software installed on the CNC machine. Hexagon technology and expertise is helping our customers improve manufacturing processes and improve product quality. We invite you to bring us your machining challenges.